Hey guys, welcome back. We're going to try part 2 of rational functions. And so today we're actually going to graph them and see what they look like. We will do most of, or at least some of it by hand, and then use Desmos to give us a better picture of what it looks like. So let's go ahead and start with what we were looking at yesterday and go from there. So let me get a second to turn this over and get situated. So remember yesterday we were looking at asymptotes and how they could be found. And so hopefully you practice those 4 that I left you with, and we will start one by one with those. Okay, so again, I'll remind you to go ahead and stop and take a break if you need to. Pause it. Okay, this I know can get tedious just sitting there, so don't forget to take care of yourself just so that you can pay attention. So let's go and look at the function y equals -3 over x plus 2. I believe that was the first one I gave you yesterday. Okay, so the first thing I asked you to do was to find the vertical asymptote. And the way we did that is you took the bottom and you set it equal to 0. Okay. And in this case, we get x by itself by subtracting 2. So we end up with the vertical line x equals -2. Okay, so this rational function has one vertical asymptote. Okay. Next, we look at our horizontal asymptote. And as you recall, hopefully, we found our horizontal asymptote by comparing our degrees. And so we look at the top degree, and in this case our top degree was 0 and our bottom degree was 1. And so we ask ourselves, how does 0 compare to 1? And it is less than. And so if we go back and look at our 3 scenarios, this tells us that the x-axis is an asymptote, or we could also write it as y equals 0. Okay, so those were the asymptotes that I asked you to find yesterday. Okay, now today we want to use that information to actually graph this and give us a picture. Okay, so let's go ahead and just draw a sketch. And you're welcome to use graph paper, but a sketch like this is perfectly fine as well. Okay, so the first thing we want to go graph is our vertical asymptote. Okay, so x equals -2 is a vertical line. Okay, so we're going to go left 2 and go ahead and draw it as a dashed line. Okay, so and it's a good idea to go ahead and label it. So here is our horizontal asymptote. Now what that has done for us right now is actually split your graph or your coordinate plane into 2 parts. You have left of it and right of it. Okay, so we're going to have our graph somewhere to the left and somewhere to the right probably. Okay, now we go in and put our horizontal asymptote as a dashed line as well. And I know it's hard to do when it's on an axis, and so you can dash maybe off to the side if you want, or just say y equals 0 over here. Okay, but we do know now that that is a horizontal asymptote. So we actually have 4 pieces of a quadrant of our coordinate plane here. You have this piece, a lower right hand piece, lower left hand piece, and a upper left piece. Okay. If you remember from yesterday, our parent function was a hyperbola that had 2 branches, one in the top right, one in the top left. Okay. We should not be surprised to see in a few minutes that we still have 2 branches, but these branches switch because of this negative. That's a reflection. Okay, so if you'll keep your transformations in mind, that will also help you graph this correctly. Okay, so you might be staring at this and say that's not much of a graph, and you are right. All we do have right now is our asymptotes. So can you think of some important points that are on a graph that are helpful? Okay. Well, one thing that we always try to look for are our intercepts. Okay, so right now let's try our x-intercepts. Okay. Now, x-intercepts, there can be more than one. If we go back and think about what an x-intercept actually is, hopefully we can recall that that's where it crosses that y-axis, sorry, the x-axis, and so our y value is 0. Okay, so when we find our x-intercepts, we're going to plug in 0 for y. Okay, so anytime we want to find an x-intercept, we are going to plug in 0 for y. Okay, so let's go ahead and do that in this case. Okay, and so we get 0 equals -3 over x plus 2. Now, anybody remember what to do here? Okay, here we cross multiply. So 0 times x plus 2 just makes it 0, and we get 0 equals -3. Okay, does that bother anybody? Okay, this is a no solution if we were solving the equation, or in this case, that just means that there's no x-intercept. Okay, so that didn't help us out any. This shouldn't surprise us because we do have a horizontal asymptote at y equals 0, so to not have an x-intercept wouldn't be strange, okay, since that is an asymptote. Now, one thing I do want to mention, maybe a shortcut, in other words, is we will always be cross-multiplying here, and if we put 0 in for y, that's always going to knock the bottom out. So for a shortcut for an x-intercept, okay, you can just set the top equal to 0. Okay? And it's okay if you forget that, but that is one of those quicker methods if you can remember it. Okay? So just like an x-intercept, we can also look for a y-intercept. Okay? And unlike an x-intercept, you can only have one y-intercept. Okay? Can anybody think about why that might be? Well, the reason is this is a function, and remember x values can only have one y, it can't be repeated. And so if you had two y-intercepts, it would flunk the vertical line test. Okay, so that's the reason I know it can have only one at most. Okay, so to do a y-intercept, we plug in 0 for x this time. So we get y equals -3 over 0 plus 2. Or in this case, we get -3/2. Okay, so what we can do there is go to the y-axis and go down 1.5 and put in, or put our dot there. Okay, so still not very much of a graph. What we do know though is that part of our hyperbola should be down in that right coordinate part. Okay, and we had kind of reasoned that out already since we knew it was a reflection, but this confirms it. Okay, so I would hope to see a branch that goes up like this, and then over here in that top left have a branch that goes up like that. Okay, so we've done our asymptotes, we've done our intercepts. How are we going to find the rest of our graph? Okay, well, we can always do a t-table. Okay, if nothing else, that is one way that we can fill in a graph, and that's just by picking numbers for x, okay, and finding out what their y partner is. Okay, so let's concentrate over here and see what we can get there. So we already know what 0 is. Let's go ahead and find -1. Okay. So if we plug in -1, we get -3 over -1 plus 2, okay, which -3 over 1 is just -3. Okay. Let's go ahead and do maybe another piece. Let's do +1. So if we plug in 1, we have -3 over 1 plus 2. And so -3 over 3 is -1. Okay. So let's go ahead and graph those 2 points. Should get us a better picture right there. So if I go down left 1 and down 3, and if I go up to 1 or over to 1, excuse me, and down to -1, it does look like I should have a graph that's doing something like that. Okay? Because again, I know this is a hyperbola. Okay. What about that left-hand part? I mean, I'm fairly confident it is in that top left piece of our graph, but let's go ahead and look. So we've done -1, -2 is not allowed. So let's go to -3. So we take -3 over -3 plus 2, okay, which gives us a -3 over -1, which gives us a +3. Okay. So that's comforting to know that it is now above the x-axis. Okay, so probably in pretty good shape. And then let's take -4 just to confirm. Okay, so -3 over -4 plus 2 gives us -3 over -2, which is +1.5. Okay. So we are going to the left here, and it looks like we're getting smaller, so that's what I would expect to see as well. Okay, so let's graph those 2. And so go left 3, and we were up 3, and we were at -4 and at 1.5. Again, I would feel like it would do something like this. Okay. We are not expecting perfect pictures. We're wanting to see your asymptotes labeled, your intercepts labeled, and then you using the information that you know about graphs. Okay, so I would expect to see for sure your intercepts and your asymptotes, and then you could go check at Desmos and make sure that you are okay. So let's go ahead and do that. And again, you can use your graphing calculator as well, but Desmos is again fairly friendly to type into. So we have -3 over x plus 2. And if you look, it looks like we should be pretty good. If we want confirmation, here you do have a y-intercept of -1.5. At 1, I mean, not, it's -1, which is what we had. Okay, -4, you can tell that it was 1.5. We had that as well. So it looks like we did a pretty good job. Okay, so let's go here a minute. So hopefully that shows you how we do our first one. And let's go ahead and now look at our second one. I asked you to now try, let's see what it was. It was y over x squared plus 4x plus 4. And so let me take you back to Elmo. Okay, so right there. And so for the second one, okay, give me just a second. Okay. So we have y equals 2 over x squared plus 4x plus 4. Now this one, since we have an x squared on the bottom, we may not be as confident as what it looks like. We know it has some branches probably, but it doesn't necessarily have to be a hyperbola like we saw before. When we looked yesterday, when we had x squareds, we did have 2 branches, but they tended to be in the same direction. Okay, and so let's go ahead and see what you got for that. So I did ask you to find the vertical asymptote, and we do that by setting the bottom equal to 0. And this is a quadratic, so you could have used the quadratic formula, you could have completed the square, but possibly most of you just factored it. Okay, but whatever it took to solve that quadratic, and here we would get x is equal to -2. Okay, so like our previous one, we do have a vertical asymptote at x equals -2. Okay. Then I asked you also to find the horizontal asymptote. And again, we do that by comparing the degrees. Okay, and our top degree is 0 again because we don't have an x. And the bottom degree is 2. And 0 is less than 2. So that means that the y-axis is a horizontal asymptote. Excuse me. So we do have two pieces of a graph that we can put together. So let's go ahead and start our sketch. And again, this is what I would want to see on a test. Okay, this is definitely your asymptotes to start with. Okay, so let's go ahead and just draw a sketch there. Okay, so we found out that we had a vertical asymptote at x equals -2. Remember that is a dashed line, and we should label it. We also had a horizontal asymptote that was the x-axis. So we have y equals 0. And again, this doesn't give us much of a picture. However, we do have 4 pieces of the coordinate plane. Okay, so I'd expect to see something in probably 2 of those. Now, let's look at, see if we can find any important points. Okay, so let's look at the x-intercept. And remember, you plug in 0 for y, which actually knocks out that cross multiplication part. And so if we just set our top equal to 0, then we can get our x-intercept. And like our previous problem, we get a false statement, which means that there is no solution, or in this scenario, no x-intercept. And again, that's not too surprising since we have an asymptote at the x-axis, okay, or the x-axis is an asymptote. So then let's look at a y-intercept. And again, remember, there can only be one y-intercept. Okay, so the y-intercept says we plug in 0 for x. So we have y equals 2 over 0 squared plus 4 times 0 plus 4. Okay, which in this case tells us that, oops, sorry about that, off the paper, that we get 2 over 4, so we have 1/2. Okay, so we have a y-intercept of 1/2. So it looks like something will be going on in that top right part of our graph. Okay. And theorizing from our exploration yesterday, since it has x squared and we have them in the same direction and everything, probably something else going on over here. Okay, but we'll confirm that in just a few minutes. Okay. So without going to Desmos yet, we will want to do a t-table and plug in some values for x and find out what the y partner is. Okay. So over here, since I'm looking at this, I'm going to go ahead and look at -1 and see what happens when I plug in -1. Okay, so y equals 2 over, how do I want to do that? Okay, so we have -1 squared plus 4 times -1 plus 4. So we get 1 minus 4 plus 4. So we get 2 over 1 or 2. Okay, hopefully that's right. Okay, and then let's go ahead and look at maybe +1. So we have y equals 2 over 1 squared plus 4 times 1 plus 4. And in this case, we get 2/9. Okay, so if I go ahead and graph those, if I have -1, I'm up there at 2. And if I have 1, I'm down here at 2/9. Okay, so I'm going to hypothesize that it curves down like this. Okay, but we'll use Desmos in a minute to confirm. I don't want you spending all your time on a t-table, but I do want you to remember that the t-table is a tool that we can use if we don't have a graphing calculator, or to get at least a general picture and use a graphing calculator or Desmos to confirm. So let's see what's going on over here. So let's try -3. Okay, so if I have y equals 2 over -3 squared plus 4 times -3 plus 4. So we get 2 over 9 minus 12 is -3, and -3 plus 4 is 1, and so it looks like I get 2. Okay, at -3. And then let's do one more, so let's do -4. And so I have 2 over -4 squared plus 4 times -4 plus 4. Okay, so I get 2 over 16 minus 16, which is 0, plus 4. So we get 2 over 4, which is 1/2. Okay. So let's go graph those 2 points. So I have -3, 2, and -4, 1/2. Okay. So looks like it's symmetric, right? Looks like they're folding. So let's go ahead and look at Desmos and see if what we are theorizing is correct. So we have 2 over x squared plus 4x plus 4. And can you tell me why my graph doesn't look like it should? Well, that's because I either messed up on the paper or I messed up typing in Desmos. And so something concerns me that this is upside down. And so that would trigger a reflection to me. And if we go look at Desmos, I typed it in wrong. So let's go ahead and take that negative out. And now that looks more like what we are expecting to see. Okay, so do notice that -2 was your vertical asymptote, and it is a reflection or symmetric like we hypothesized. Okay, so let's go ahead and finish what that graph looks like. So something like that and like that. Okay, so 2 problems down. Let's try a couple more. Maybe would now be a good time to go take a break if you haven't and come back. Okay, so let's look at number 3. Okay, number 3 is y equals x cubed minus 1 over x squared. Okay. And so we need to find the horizontal, or excuse me, the vertical asymptote. Doesn't matter what order you do it in. This is just what I have developed that I always go do first. So the vertical asymptote is our bottom equal to 0. So x squared equals 0. So x is plus or minus 0, which is just 0. Okay, so this is your y-axis. And I realized I told you wrong on number 2. I'm sorry, that was your x-axis, not your y-axis. So make sure you switch that. I apologize. So it's y equals 0, but the x-axis. Okay, so here we have the y-axis is going to be our vertical asymptote. Okay, and let's go see if we have a horizontal asymptote, and if so, what it is. Okay. Horizontal asymptote totally depends on the degrees and how fast our top and bottom are getting bigger. And in this case, our top degree is 3, and our bottom degree is 2. So the top is bigger than the bottom. And in that case, this is the scenario where we have no horizontal asymptotes. Okay? But what we could have, and we'll see in our graph whether or not we do, is one of those oblique or slant asymptotes that I mentioned yesterday that we don't really have to know about, but we'll see if it actually shows up in this one. Okay? So vertical asymptote and horizontal asymptote. Let's go ahead and get a sketch going. I'll try to squish it in here. Okay. So our y-axis is our vertical asymptote, and then we don't have a horizontal asymptote. So what we do have right now is 2 parts of the graph. Okay. Although if we have oblique asymptotes, we would have it split some more. Okay. But in this case, we just have 2 parts. Let's go ahead and look at a x-intercept. Okay. To get our x-intercept, we plug in 0 for y, or we just set the top equal to 0. Okay, so x cubed minus 1 equals 0. Now, if you remember this, we actually need to factor and get 3 answers. However, if you will remember, this is when we have a difference of cubes, and so we would factor it into x minus 1 times this x squared, and then we change the sign and then squared this last one. Okay. And so we do get x is 1. Okay. Now, these we should get 2 more answers, but these 2 are always imaginary, so I'm not even going to worry about that. So what I do know, though, is that I do have an x-intercept of 1. So I'm going to go over here to 1 and put an x-intercept. Okay. Now a y-intercept, we plug in 0 for x, and what happens here is we get 0 on the bottom. Okay, so we cannot have a y-intercept. It would be undefined, and we definitely cannot have a intercept on a asymptote. Okay. So we really have an unclear picture of what this looks like. So let's take a minute and go ahead and see a few values in the t-table. Okay. So let's take, we have 1 up there, and we know 0 is a boundary, so let's try 2. So we get 2 cubed minus 1 over 2 squared. So 8 minus 1 is 7, and 2 squared is 4, so we get 7/4. And then if we do 3, we take 3 cubed minus 1 over 3 squared. So we get 26/9. Okay. So if we went to graph that, 7/4 is what? 1 3/4. So we go to 2 and we go up 1 3/4. And then if we go over to 3, we have 26/9, which is almost 3. Okay. So I'm really not sure what that's going to be. It should not be a straight line. Okay, we know that much at least. Okay, and then let's go ahead and look on the other side of our thing. So let's do -1. So if I take -1 cubed, minus 1 over negative 1 squared. Negative 1 cubed is negative 1, minus 1 is negative 2, okay, over negative 1 squared, so we do get negative 2. And then if we do negative 2, looks like we'll get negative 9 over 4. So let's see what that looks like. So negative 1, negative 2, and negative 2, 9/4. So that is, what, 2 1/4? Oh, oops. I put that in the wrong place, didn't I? Okay. So negative 1, negative 2. And then negative 2, negative 2 1/4. Okay. So we have something going on. Let's go ahead and look at Desmos and see what it might be. So we have x cubed minus 1. And we have x squared on the bottom. It's always kind of fun to look at Desmos and see what it changes to as you go. But, okay. So here you'll see that we have a totally different graph than what we've seen in the past. Okay, but we do have that vertical asymptote here. Okay, and we have something going on here and on this side. Okay. If you can look with me a minute, can you envision a diagonal line that's right here? Okay. Well, that would be a slant asymptote, which you could learn more about later. But if we zoom out, we kind of see what it does look like. Okay. So we did fine on our picture. We just want to go ahead and finish it out. Okay. Let me get it back one more where it was. Okay. Mine got kind of flattened out. Looks like it goes like that. Okay. So we're not expecting perfect pictures again, but more of it is being able to find the picture when we need it. Okay. So I'll let you see what I finished there. So that's kind of how I finished sketching it on mine. But again, labeling your asymptotes, knowing your intercepts, and knowing how to find your t-table is very important. Okay. So let's look at briefly number 4 that I gave you yesterday. So number 4 we had y equals 5 over x squared plus 4. And I realized that I didn't choose all my problems very wisely yesterday, but hopefully it gave you some practice. Okay. So if we go to our vertical asymptote, we set the bottom equal to 0, and we find out that we don't have any because when we take the square root of a negative, you get an I, and I's aren't going to show up on our real graph. Okay, so this is one of those rational functions that does not have a vertical asymptote. Then if we go and look at our horizontal asymptote, to check on it, we compare our degrees, top versus bottom. Top is 0 and our bottom is 2, so we get less than, which infers that we have the x-axis as our horizontal asymptote. Okay. Next, let's go ahead and see if we have any intercepts. So if we look at our x-intercepts, we plug in 0 for x, 0 for y, set your top equal to 0. We get 0 equals 5, which again is not true, so we don't have an x-intercept. Okay. And then y-intercept, we plug in 0 for x, so we get 5 over 4. Okay. So we do have one y-intercept there. So if we go ahead and graph that, and let's see, x-axis is our horizontal asymptote, and we have a y-intercept of 1.25, and I drew that badly, so let me switch. So 1.25. Okay. So now again, you can plug in and do a t-table, but for the interest of time, let's just go ahead and look at Desmos. In this case, again, you have shown me your asymptotes. You've shown me the y-intercepts, and so now I would be fine with you graphing, although I do want you to know how to find other points. Okay, so we have 5 over x squared, okay, plus 4. So we get like a hill. Okay, and believe that y-intercept is our height. Okay, so just have a little hill here as our graph. But it does match everything that we had stated. Okay, so just go up there and do that. Okay, so let's go ahead and do one more. And I know this isn't a huge amount of problems, but they do take quite a bit of time. If you think you need more examples, then just email me and I would be more than happy to write some more out, not necessarily video them, but write them out and get them to you. Okay, but it's just more about knowing the process, okay, finding the horizontal asymptote, the vertical asymptote or totes, the x-intercept or intercepts, and the y-intercept. Those are extremely important. And then graphing and looking at Desmos or your graphing calculator to see what the rest of the graph is. Okay, so again, right now we're looking at what the important pieces are. Okay, so let's look at one more. And let's look at x over x plus 4. So let's start with our vertical asymptote. Okay, and we have y equals x over x plus 4. And I don't know why I wrote that twice, so I'm sorry. Let's just take the bottom. How's that? So x plus 4 equals 0. So x is negative 4. Okay. So we know we have one vertical asymptote. Let's look at our horizontal asymptote. And again, this is when we look at the degree of the top and the degree of the bottom. And in this scenario, we have a first degree on the top and a first degree on the bottom. And so 1 equals 1. Okay, so this is the scenario where we look at our lead coefficients. Okay, and so the coefficient in front of x on the top is 1, and the lead coefficient in front of x on the bottom is 1. Okay, so we just take 1 over 1 and we get y equals 1. Okay, so I know that's the one that I forgot to give to you as a practice problem yesterday, that scenario, but you should have an example from yesterday and this one as well as how to find that. When they're equal, you just take lead coefficient over lead coefficient. Okay, so we have the vertical asymptote at negative 4. So again, I ask you to use a dashed line and label it as x equals negative 4. Okay. And then we do have that horizontal asymptote at y equals 1. Okay. So go ahead and label that as y equals 1. Okay, so let's go ahead and look at, see if there's any x-intercepts. So again, you plug in 0 for y, we cross multiply and it knocks it out. So really you're just looking at the top and it says that the top is equal to 0. Okay, so we have an x-intercept at the origin. Okay, which if you think about it, we should automatically know what our y-intercept is. It's got to be the origin as well. Okay, but we can confirm is 0 over 0 plus 4 is 0. Okay, so really we just were able to get one intercept out of that, but it does help. Okay. Now, again, I would encourage you to be able to use a t-table, but again, in the interest of time, let's go ahead and look at Desmos. Okay, so, and we want to have x over x plus 4. And I have too much or something. There we go. Sometimes it's better just to start over. Okay, there we go. And as you can see, we do have an asymptote at -4. That's where our graph jumps. And we do have an origin for a intercept. And so I would say that we did a good job when we set up our preliminary graph. Okay, so if you wanted to, you could have gone over and clicked to see what some of these specific numbers are, but I'm okay with it just a sketch over here as long as you have your asymptote. And then I should have looked a little bit closer at it, but try to use Desmos to get a decent sketch. Okay, so we're going to leave it at that. Let's see. So we're going to call that good today, and just remember that we are finding the vertical asymptote and then the horizontal asymptote by using our two rules that we looked at yesterday. And then we also want to use the x-intercepts and y-intercepts because they are important, as well as our t-table. Okay, so go back, look through these. Again, if you feel like you need some more to practice or want just a few more for your notes, then just email me and let me know. Okay. Tomorrow, my plan is for you to get on Desmos. I'll make an activity where you just answer questions, multiple choice or looking at the graph, as well as a matching activity to get more comfortable with that. And then we will kind of see where we are from there. Okay, so again, I know this is kind of long, but we do have a lot we have to get through this, and hopefully this is a way that will work since this is kind of what we're used to. But let me know if you have any questions, and I will talk to you soon.